Okay, but how will I structure today? It will be very similar, I guess, to what we did with any other element. I will take quite some time for theory. And again, I'm warning that it's going to be quite simple theory because there's not so much information that you will learn today, which is will be new for you. But it is, in my eyes, extremely important to understand what water is and why it reacts in a certain way and when it reacts in a certain way in order to compete properly and in order to compete not with too much pain, I would say. Okay, so let's go. So the first picture that you see is definitely not water. You already kind of like realize that it's mercury and it's a metal and it's very reflective to any direction, like a mirror. More water is not reacting like that. I will go now one by one and we will just kind of like make a shopping list of the properties of the water that we would like to replicate in our comps when we're comping. So later it will be just basically, well, did I do that? Did I do that? And then in the end, when you look on the final result, you will say, well, that probably looks like water. And if it's not, maybe I'm doing something incorrect there. So let's go for just the very first kind of like, that's my list. It's not something that kind of like, you know, that's it. That's the whole lesson today. I collected just a lot of a lot of pictures that we will watch today, and we will just start talking about that. So the first thing that I would like to touch with water is reflections. Okay, so water is pretty reflective, but unlike the mirror, it's not reflecting to any direction 100%. Okay, so it will always have a certain amount of reflection when we're facing the water 90 degrees, and then it will be more and more and more of reflection from the moment we making an angle higher. So this is extremely important when you're trying to create water from scratch, for example, or doesn't matter. It's extremely important to know this very kind of like simple fact. Okay, so why does it happen? Okay, so first of all, we can observe that easily. Okay, in any shot of the water, when we're looking on the waves, you see that wave is black when it's pointing towards us, and it's water is very reflective from the moment the angle is starting to be higher. Why does it happen? Physically, there is quite complicated formulas, but basically the best explanation that I received on internet that I found, it's imagine that you have a bullet that is flying towards the wall, and this bullet is a photon, which is light. Okay, when bullet is flying and hitting the wall directly, it will go through the wall. Okay, from the moment you're starting to rotate wall, there is less and less energy wall need to spend in order to deflect the bullet. And that's exactly what's happening with reflections. Light is flying, it's hitting certain energy and a certain object, and if it's hitting 90 degrees, it will just go through. Meaning we will lose this light, which will go inside, and we'll talk about what's happening to this light later. But from the moment we're starting to rotate, it's just deflected, and that's why we see all these reflections, and that's why we really need to know about Fresnel. Okay, Fresnel, that's what we're using, and in order to take certain amount of reflections and not to take the rest of reflection. So we will not create a water which looks like a mercury when we're saying, well, something is wrong there. Well, of course, it's reflective all over the place. Okay, I will jump to Fresnel later when we'll go to practical thing and we'll touch that. But first of all, reflection, again, that's a first thing that we need to take care of. Okay, that everything which is pointing towards us, we're losing reflection. And let's have a look just on the second part before we will finish with reflections, because there is not only one reflection that's going to happen, there is another reflection that's going to happen. It's internal reflection, and this is the coolest thing I didn't know, and that's the best example of external reflection that I can show you. So the light that will go through the water, not one which is reflected. There will be some which will go inside. It will go through the water as material, it will hit the ground, and then it will reflect back. Okay, and that's an important thing, that not all light will come back. Very little amount of light will return to the air, to the atmosphere. And here there is amazing thing happening that, again, I kind of like have hole in my education. But when the light is coming from the more dense environment to less dense environment, there is a thing which called full total reflection. After a certain angle, there is a zero light escapes the dense environment. And that's something that's crucial for us to be able to talk to each other, because that's what is used in our optical internet, and that's the law that kind of like they're using. So after something like 45 degrees or even like less, I'm not so sure, we can see that there's no light escapes the water. Okay. Meaning when you under the water, when you're close to the surface and you're looking on somebody which is inside of the water, you will see full reflection of this person if water is completely still. Okay, so there's no light from this guy will go out, okay, after a certain angle. Why is this important for us? Because I ask the question, why everything which is wet is black, is dark, or most of the stuff is dark? Well, is something happening to material that we making wet? Well, not exactly. There's just water is on it, and the explanation is that light is trapped inside of the water itself. It's going inside and then it's reflecting from the ground to all directions, and of course only little part of this light is coming out. That's why from the moment we have a rain, all the ground immediately starting to be dark. Okay, that's why oceans are pretty dark, and except of additional stuff that's kind of like water itself kind of like consuming the energy and consuming the light, or absorbing the light, sorry. So that was the total reflection, that was the internal reflection, and it is different from external. That was something that I didn't know. That's actually when you looking from outside, water always will absorb something and reflect something. From inside, there will be total reflection of the light in certain moment. And that was cool thing that I will show you just because it's cool. That was some kind of like very cool video showing an example of light not managing to escape the water after certain angle. So basically this is the laser beam which is beaming in the water, and as you can see, it's just bending together with the water which is going down, which is quite cool. Then let's talk about refraction. Okay, so now we have two things to pay attention. First, a reflection from outside with the Fresnel, of course. Second, it's to darken anything which is under the water, because light is trapped and we're not getting enough rays out to make the surface as bright as it was previously. Now, so that's just only reflections. Now let's go for refractions. This is, again, it's very old video apparently, but it's the best example that I was able to find, so it will be really clear what is happening. So what's happening, the speed of light is different in different mediums, okay? So when light is going in a vacuum, it's a certain speed. When it's inside of atmosphere, it's starting to slow down. When it's hitting some other objects which are transmissive, it's slowing down even more. So water is denser than air. The densest one from transparent object that kind of like, I think it will be a diamond. So speed of light is really significantly slower there. That's why it's way more refractive. And why is this refracted? And this is quite cool explanation. You see these waves, this is waves of light. So basically this is the same picture which is coming in the same time. From the moment this guy is hitting the water, he's starting to slow down, while this one way faster, still flying there. And that's why this guy is already slowing down for some time. In the same time, this guy will faster arrive to this destination and will start to slow down later. And that's why all the rays which are arriving there are bent. Okay, again, there's similar, there's not similar, there's kind of like there's index of refraction that I mentioned already. So different objects will have different index of refraction. As well, if an object is thicker, you will have more refraction than thinner object, because there's more matter that the light will have to go through, and the more angle, the more refraction is happening. Okay, so if you're going 90 degrees, you just will go straight. There's nothing to refract, because the waves will arrive in the same time. If it will go up from top to bottom, it will just hit it, slow down, and will keep going. Okay. Now, but the bigger the angle, the longer the second part of the wave will have to travel with a higher speed, and that's why refraction is way, way higher on the edges of any object. That's why when you see something like that, the refraction in the middle will be 1 and on the edges will be really, really strong. Okay, we'll get back to this ball today. Oh, look at this, this is another one. Cool. Okay, so that was the refraction. So far questions, some stuff that not clear or you want to add something? Okay, so I'm recollecting again, outside reflection, inside reflection, and refraction. Okay, so let's go to next one. Next one will be the drop of water. And that was cool 4K video I shared last week as well, because it's just cool. So this is the drop of water in zero gravity, and some astronaut, somebody told me that he's even German, having fun with it. And what I want to talk about, I want to talk about the actual water as itself, as kind of like as H2O, basically. Water has quality of surface tension, okay? So it's always trying to collect itself in one unit. And this is important for us to acknowledge and understand that it always will try to gather itself. Why? When we're comping different sizes of water, we always need to see if we're actually able to use certain element to portray certain behavior of the water. So if you want to say that this is very big explosion and you have some kind of like, you did shoot in studio, you did throw the stones and you've got some kind of water splashes, you cannot sell it, because when you're making little water splashes, water still able to hold together and it's not breaking. It's kind of like, you see that splash is small, and again you kind of like, well, of course, but you need to think about this, you need to remember that. Or when you want to portray huge wave and you have little waves, and now we're also arriving to the time kind of like, for example, you have a material which with the small waves. You did it inside of the, I don't know, little bucket. You created the waves, somebody created for you, and you need to sell it as a huge wave. So you will have to slow it down. Okay, so this is next thing. But then even if you will slow it down, this little wave is not going to behave in the same way as a huge wave will behave, because the huge amount of water will collapse in different way because it's just bigger size. Okay. And kind of like that's where this surface tension is coming in place, that with little water you not always can get away just with the faking stuff like that. Okay? Okay, now, so then we have, just a second, we have next one. Let's talk about diffuse properties of the, I think here I have just very simple thing, tick, this one. Fine. Color of the water, okay, diffuse properties of the water. So our light, we spoke about the external reflection, our light will go inside of the material and then it will hit water itself, and water will start to absorb light. Okay, and from the structure of water and from the way, I have no idea, chemistry, physics, I don't know why, but basically water will absorb the infrared side way faster than ultraviolet, or like the colors, that red colors will be absorbed very fast. That's why when light will keep traveling, deeper you're going, the more blue environment is becoming. So another thing, you want to tell story of the deep water, you have to start to dim down the rest of the colors, you're leaving the blue channel, and that's how you're getting basically the right, physically right approach to say, well, we are very, very deep. Okay, so that's the diffuse color of the water, and it's just as water itself. Let's say we're not adding we're adding zero materials to that. It's just purely, that's what you will have. That, like even in pool, you already can see that it's slightly bluish, and it's not because we have a lot of chlorine there. Okay, no, it's just water. And Doug again is breaking my presentation here. Doug, I will have a look in the end when we will have time. Thanks. Then let's what else can we do tell about diffuse? We just need to remember that, okay? The deeper is water, the more light is absorbed. The less shallow the water, less light is absorbed, and so on and so on. Next one, sea foam. There's not much that I can tell about sea foam. Actually, I was like thinking, okay, what can I explain about that? Well, there's kind of like some facts that sea foam, it's created from algae and dead animals, okay? So basically, you're not going to have a sea foam in the pools, okay? It just can be created in areas when you have like life, basically, okay? Another thing that it's basically, it's just from my personal experience, but it's not crazy important. It is like, I remember like suffering quite a lot trying to track sea foam to the water because of the software that Rodrigo mentioned was not able to do it properly, and it was sliding all the time. Otherwise, I don't have something to add. It's just observations, how it behaves, and trying to mimic that when you're trying to fake the water. And like there are cases that you will have to do it. Let's go to next thing that you, I think, could and should pay attention when you're comping the water, and I think it's quite cool one. That water will have different refraction with different temperatures, and that's something that we can observe in the underwater videos. I didn't find defined ones. I saw once video of a friend of mine diving in some cave, and there was very warm water going, just very cold water, and then was very warm stream coming out of somewhere, and when he was shooting from underneath the water, you really see the different refraction. And that's something that also we can deploy to say, well, we are inside of the water, because when you outside, you're in the room, and you have different temperatures in the room, you're not going to see that. You're going to see that very well when you have very hot rod. That's something that we kind of like probably doing this quite a lot. We're starting to make heat distortion. The same is happening in water, but it's way more kind of like easier to create and see it in very close distance, and you don't need very crazy temperatures to do that, okay? The difference shouldn't be such a huge. So that's another thing. I saw one example of that in the movie that Oslo Skyline did with the shark, the latest huge megalodon a few years ago, and I kind of like, I saw them trying to implement that. I didn't find it very successful what they did there, I have to say, but I saw this, oh, okay, this guy's kind of like actually trying to say that this water is very hot, and trying to show that it's slightly kind of like distorting stuff. Next one. Well, I already mentioned about the size matters and the shooting miniatures. Okay, so basically, if you're trying to fake, like for us as compositors, we're not shooting miniatures, but these guys, for example, they're trying to. I will show the final result, I guess, and I think it's quite convincing. Basically, you always have to to pay attention to the speed. Okay, that's it. So you have to shoot everything with a high speed in order to make slow motion. There are certain formulas for the size of the miniature. For us, it's what is for us important. We're not shooting the material, but frequently we will have an element, and then somebody will ask us, can we take this wave and put it here and then make it bigger? Well, we can, but you will have to think, okay, how big this wave is supposed to be, how high this wave is. It supposed to be so fast, or it's supposed to be slower? Okay, so that's something that kind of like you definitely going to meet when you're shooting, when you're trying to fake ocean. Another thing that I would like to mention, it's something that I would highly recommend. And again, I'm talking about now about ocean, but I think any water. So it's flat surface. And when you're dealing with that, I don't know how many of you were in a workshop about the fire, when I was working on the shadows, contact shadows. And instead of painting contact shadows in a perspective, I was unwrapping the material, then making shadows on unwrapped material, and then wrapping this back. So my big advice, and now it's theoretical, but we can also touch it in practice. I think we will have plenty of time today. It's when you're working on the surface with this, which is so flat, it's super easy to unwrap it. Meaning, you're taking your ocean, You corner pinning this. You can just corner pin it. If it's still camera, it's no brainer. If it's a tracked camera, you also can stabilize this, unwrap, and then work on your material. Why is that? I saw a huge amount of comps when people trying to create, so for example, we need to create an ocean, and then we're getting some DMP stuff. Here and there, they're throwing things, and then VFX soup starting. I wanted here more waves, here less waves. And people trying in perspective, take the wave from the left side and move it to the right side. There's no fucking chance, like no way it will work in the world. When you're taking one from one perspective, moving to another one. From the other side, from the moment you're unwrapping that, and you're moving this in like UV space, from top to bottom, and then you're putting this back, it will preserve like all the perspective stuff, or most of them. If it's not kind of like very, very close to us, most of the things will still work with the speed of the water, with the size of the water, with the behavior of the wave. Okay, so when you're working with something which is so flat as an ocean, as a water, always recommendation, spend the time, like prepare your setup to unwrap that, work it unwrapped, and then put it back, you know, very simple. Stabilize, work, and unstabilized back. Okay, so that's experience, kind of like a tip. What else? So we will summarize in the moment, but this is cool. So I brought it just because it's super cool. Then we can kind of observe quite a lot of things that I was mentioning about, for example, the refraction on the edges, the reflection on the edges, and the water tension as well, kind of like all this thing, like, you know, 1, 2, 3, 4. There's another cool thing that is happening with the water, especially when it's consolidated, is this. You see this lens effect on the wall? And that's quite important, just in general for the look of the wall. And now let's talk about the rain. Okay, so rain, it's also kind of like of course, water, it drops, which looks like that. And about the rain, when we're comping that, I also kind of like saw quite many examples when people not exactly understand how it's supposed to look like, basically. And I want to explain why it's supposed to look in the way that kind of like it does look in the nature. Do I have rain somewhere? No, I don't have videos of the rain, and I was watching many of them. But basically, when you're shooting the rain, you want to backlight the rain all the time. If you, in the night, let's talk about the night. So when you're shooting rain in the day and you kind of like, let's talk about night, because day it's a little bit different story. So, and you lighting the drop, and that's the drop of the water, okay, from the front. And like, that's very simple example. I kind of like tried, it did work. Okay, so that's what you're going to get, okay? I'm lighting this from the front quite a lot, and it's just getting some reflection in the middle, and hopefully you see that, but you're not very impressed by that, okay? From the moment you're lighting from the back, you're getting huge light. And even if I'm going left, I'm going right, and that's only one drop, okay? So this is a very simple thing, but that's something that you really have to remember. Now imagine night, and imagine street in the night, in the street lights, okay? When you try to put water, you're getting render from the water, and then some people will just take it like, well, I will put it like that, because that's the water, and it's supposed to be visible. And then you're getting water visible where it's not supposed to be visible, in dark areas. It's supposed to be visible only in the areas where you have a light, source of the light, because what you see, it's not diffuse getting brighter. No, what you see, it's only refraction. That's what you see. It's motion blurred refraction, meaning your rain is going to be visible only in front of the lights, not behind the lights, because when the rain is behind, it will reflect little dot of the light. The rest of the light will go through the water, will be absorbed a little bit, but you're not going to see that because it's very transparent. Okay, so that's how you comping the rain, basically. You're extracting luma of your sources of the light, slightly blurring this, and then you plusing this through the alpha of the water that you're arriving from 3D, okay, or that you're creating with your particles, and then you're getting a proper reaction on the how stuff's supposed to behave. That was rain. I think this is it from theoretical stuff. Now let's have a look. What do we have here? Oh no, look at this. I have it. Okay, so Some cases of water we could encounter clouds. We spoke about this last time. Okay, so I'm skipping now clouds. Rain, I actually did collect that. So now let's just observe, like let's collect all this information and observe a little bit more. I'm kind of promise we will be done soon with the talking. Okay, so this is rain in the night, and now check this out. This is quite dark area, and you don't see water almost. Okay, you see a little bit in the close. There is a not water, a rain. There is like something we can see. Maybe this is light of the man standing with the camera, but there is a huge amount of water which is going down of the rain. Okay, all we see it's reflections on the ground. Okay, and the puddles and so on and so on. Now let's have a look on something else. This is the rain with the, which is backlit. Now that's not 3D. That's real. Okay, so I was sitting on this and I was like, well, is it? And it is. So you have some light under the roof, you have some very strong backlight, and you really see very well the rain. Now, in which areas you don't see the rain? In the areas which are in shadow, when there's nothing to refract. Sorry. Okay, so this is quite a big deal when you creating the atmosphere. Now, also have a look on this. It's deflected drops. It's quite cool. It's quite interesting touch that you're not going to get most likely when you're comping this, because you're not going to get this layer from effects. You're not going to create this layer. But this is, for example, super easy to create. It's just if you're just adding some noise, making this blurry and adding in very little transparency, and it's already you creating complexity. That it's not one layer, but it's few things, and you kind of like, well, I was thinking about this, I was thinking about that. Okay, have a look on these little drops. Same stuff that we already know, but now puddles. Today I will show how to create a puddle, okay? But basically I collected one of them just to have a look, okay? There's one thing with the puddles, just that helps, that it's, you remember this water tension that I was talking about? On certain moment, water tension is kind of like it's breaking when the material is starting to absorb the water. And that's why puddles all the time will be like, you know, you see the really water which is holding together, and then some just dark material around it, which is, you don't see that it's water. There's no more reflection, because water is absorbed by element and it's so little that's not able to reflect uniformly. It's similar that I was when I was talking about the clouds, that clouds are the water. They're reflecting a lot of the light, but since the water is so little, it's reflected to all directions, and it's not uniform reflection anymore. So here, for example, we can see the puddle, but then some areas which are dark on the edges, which is not just dirt, but it's just wet areas. And that's one of the things, little touches that you can add. Rivers, nothing crazy, I don't know. I have sweat. And that was cool one. I brought it just because it's cool, actually. I never did comp sweat. So I don't know. It's mostly like, can we remove this? Because they didn't have time to put sweat. But basically, if you look on the sweat and you understand what the thing is, you also have more tools to, this is, I don't know, it's then like so stupid video for like half an hour, to remove it or to add it. Basically, sweat, yeah, little bubbles, reflecting stuff, okay, nothing crazy. And there is one thing that I did comp few times in my life, and not this sweat, sorry, that was a cool one. It's tears, and I have even more tears. And here actually I do have again a kind of like advices from experience and the things that we already can implement from theory. So when the when somebody's crying, the area where where the tear is going, the tear line actually, it's starting to be darker. Okay, that's something that we already can see even with this little amount of water, that some light is kind of like is absorbed there. Then there's always will be the leading edge of the one drop, and I would highly recommend to you to have a look how to draw a drop, because there's many tutorials about that, because there's so many things that I'm talking about right now, and it's showing you how it's consolidating light, how it's creating the shadow, and that's something that can help you. You can create very realistic drop just with the tools of Nuke, without any particles, without nothing, just by absorbing the material and saying, well, first I will darken, second I will create a path, which that's the path that will next. This path is supposed to be properly tracked. That's important. It cannot slide. okay? And then you will just reveal a drop, and you will create leading edge. And that's like, you know, that's exactly the elements that I'm talking about now, that you need to make this list, like that I'm making list right now with a reflection, internal reflection, refraction, diffuse, absorption, transmission, and all these things. From the moment you put all these things together without using your brain or artistical kind of stuff yet, you already will have amazing base to advance. So that's cool. Drop, and you see now it's lost visibility because now it's pointing downwards where there are no lights. There's nothing to reflect. It's also cool. And we're catching again with the leading edge. Okay, I don't know. I like this. Let's keep going. Explosions. Why did I put explosions? Basically, explosions is just example of very different behavior between big amount of water and small amount of water. So as you can see, there is no water tension. There's like no. That's huge explosion. Water is hitting the atmosphere and collapsing immediately. So that's why you really kind of like have to pay attention to what is the size of your water element, because it just doesn't behave like a water. It's just like, hey, dude, it looks weird, okay? And that's actually water, okay? It just looks like completely different material. Okay, so that's I think that's it, except let's see what else I have. Okay, cool. Now, this is one I think it's helpful. Now, I'm not big art guy at all, okay? But if you're looking how painters painting stuff, and like in an impressionistic way, on whatever ways they're painting, that they're not trying to be photorealistic, but they throwing few things on the kind of canvas, and then like, well, yep, that's water. And this is amazing. This is super important for us, because we are kind of, we used to pixel fuck, and we're like, yeah, but it's really, I want this. But sometimes there is a few touches that you're doing which make a difference, okay? And that's kind of like, this is kind of like, I did put kind of like collect few examples of people that selling water. For example, this is Van Gogh, Starry Night, something. And like, you know, we see that on top, yeah, this is the sky. On bottom, that's water. Okay, this is water, this is ripples. They're starting to reflect stuff to different direction. Then here, and that's how to zoom in? Nope. Different shortcut. Sorry. Here, you see my mouse. You see, that's the wave. And that's what we're talking about. Whatever is pointing towards us is black, because there's no reflection. Whatever is on the top of the wave has very high angle, and it's very bright. It's reflecting all this light there. And just by making two lines, and that's amazing thing of painters, they're just making two lines, black line, white line, sharp, or black line like bigger, and then white line on top, and that's how cavity is created. That's how you're creating your waves. That's how the dude was created, his waves. That's another one. Here, this one is slightly different. It is looking like Mercury. So, but that's lake, so waves are not so strong. It's just created by this little ship. Still looks a little bit weird, but again, I mean, that's not photorealistic, but you very much can see that, okay, that's the liquid. Again, something which is pointing towards to us, something which has higher angle, reflecting the sky. This is more photorealistic painting, like photorealistic, I would say, it's realistic, not photorealistic, but realistic painting. Same thing, have a look. We have very, and that's also interesting, this observation. We have black, which is, again, absorption of the light, and then slowly with the angle, we're getting more and more reflection. And here, it's a very cool thing, on the edge of the wave, when it's breaking, it's very hard cut, and then we have very bright light, because it's reflected very, very strongly. Okay, so and that's one which is kind of funny one. It's again, it's somebody who is collected. It's created from the maps. Okay, somebody that cut maps on the computer probably, but it's a wave. Okay, because he said, well, what will I have? I will have stuff which are pointing towards us, which are going to be dark, stuff which are having very big angle, which will be very reflective. We will have here foam, because it's ocean. Boom, done. Okay, sold. That's it. Now it's end of kind of like theoretical and simple stuff. let's dive now to Nuke. Before I'm doing that, if you have something that you would like to add from your experience, something that maybe I'm saying that it's not exactly correct, or I'm missing something, please do it, because like, you know, there's like 40 people here. I'm pretty sure somebody has stuff which are interesting.
Just one thing from my side. You mentioned this, basically when something gets wet, it gets darker, but usually it also gets more saturated. It's not only the brightness which changes, the saturation also changes. Yeah, just wanted to add this on top of that.
I'm thinking, why will it happen? So I kind of like, it's interesting. Like I will check if and what will cause that, if like this. But yeah, Adrian.
Sorry, for a proper make in a second. I think that's mostly like you say that like total reflection thing that happens inside of the water. So like if you imagine like the ray that comes from the floor is brown, that one reflects on the water and it hits the ground again with a brown ray already. So it's like, so the brown light is like, you know, going again into the brown thing. So it's like you have like that floor color staying there, like, and you know, feedback stuff.
Okay, that makes sense. That's quite cool. Okay, so it's he kind of multiplying on himself or plussing. Yep, because the rest of the stuff are absorbed, and then he's cool. Okay, that's okay. That sounds cool. Okay, so more fun parts. No. Okay.
Yeah, sorry. It's just I was a bit slow. Like I just found this little article for anyone that's interested about water behavior. Like, just if anyone has the time to see.
Yeah, cool. Thank you very much. So let's have a look now on the some shot, guys. Please don't record. That's some clean plate from one of the projects. I'm not so sure how much kind of like we can look on this together. So let's be just careful. So I had a look on this one. Actually, I had a look not on this one. I had a look on this one. And here we have example of the rain. And it's kind of like, well, we have rain. We have all the things that we were talking about. Okay, there's quite some puddles, which are not very deep. We have very high angle, meaning the reflection is supposed to be quite strong. Okay, we also have raindrops, which are completely invisible. Okay, we just see that raindrops are hitting the ground, and I will guide you through my script. Now, again, it's my script. Okay, it's not like, guys, that's the way everyone should comp water. But what I was trying to do, I was like, well, I will show to these guys the theory. Fine. Now, I would like to comp according to the theory that I'm showing, trying to pay attention to everything that I mentioned. And that's not necessarily how I learned to comp water or learn to comp anything. I was comping and then I was justifying myself later. It's like how science works. It's like, you know, you just like, apple is falling down. Cool. Okay, let's now find excuse to that. Okay, so now let's have a look on the final result here. Again, it's comp version 1. But all elements are there. So what I did create a puddle on the left side. Okay, and I was like, well, I need this, I need that, I need this, I need that. So there's no puddle and there is a puddle. Okay, fine. Now, everyone in the company can access it from Rocket Chat. I send it in the comp so you can see it playing real time. Meanwhile, let's dive inside of the comp script, which is not such a huge script, but we can just see and talk about the kind of like what I was thinking. Okay, so first of all, the camera is moving in this shot, so let's just have a look on the camera, and it does move, so there will be parallax. Okay, that's important. That's something that already we need to pay attention to. Now, as you can see, as always, let's just have a look here. I will have my background, and then I will have my element. And in this case, my element is a puddle. There can be many elements, but I do like to collect everything by modules, and this module is dealing with water. Okay, this water will have additional elements that kind of like we're working with, and we'll see what they are one by one, and we'll tackle them one by one. Okay, so that's the big difference. When you're trying to comp on top, you just saying, well, that's the final result, and I'm adding on top this and that. But if you're splitting that, it's so much easier. It's like shader. You're creating a shader. So let's start from, let's disable. I even don't know what I'm disabling there, but I will disable everything. Okay, so and the final result after disable. Okay, so first of all, I said, well, there is a ground that I have to create for a puddle, and this ground is supposed to be dark because light was coming inside, was trapped inside of this ground, and this ground cannot be as bright as the upper surface. Okay, and that's what I did. I kind of like, I did put, let's see, what is this? I found the stone, and then I did grade it down. Now I'm showing final result because if I will compute, it took me 4 hours, so like we don't have this time. And then I said, when I already was on the ground, I created some depths there. And as you can see, that's my corner pin. That's I'm kind of like projecting. I could also unwrap this, but I was too lazy. And then I'm tracking this in. Simple tracking, projecting on the ground. There's no depths. Okay, and that's how it's going to look like. After a certain moment, so in the beginning it was looking like that, and I was like, well, that's a little bit dull. I want to add a little bit of the foreground, and that's kind of like some foreground. It's still all one picture. So we do have camera move. I could split it to 2 areas to say one is more far away, that's the back side of the hole, and this one is the front. But right now, as a base, I'm like, I don't care, like, you know, later I can separate them if I want. But right now they will come together. But important part for this is that we have a base for our water. Next one, we will add reflection, okay? And that will be this guy. And let's have a look how does it look like now with reflection 6. Because there is something to talk about reflection on technical level and kind of like. So we'll disable this. Okay, so that's the reflection. Okay, so a few things that we have to be aware of, and we need to, like, first, unlike many people telling on, guys, reflection is plus. It's not hypot, it's not screen, it's not geometrical, it's plus. You're plussing stuff, that's it. You're not plussing alpha, remember, you're plussing just a color, okay? So that's what I'm doing. I hopefully plussing. Look at that. I even doing this, what I'm saying. Now let's have a look how I was dealing with reflection because it is important. In the very beginning I mentioned we have a camera move. Okay. Additionally, we have people which walking in different depths. And that's important with reflection because reflection is, imagine camera. So the rays are coming to the camera in this way. So they're coming from the top and then the camera. So it's like camera watching on people from different angle. That's why I was not able to reflect everything in once because the background, which is here, I did put projected on the sphere. And now little trick, okay? It's simple, but it's extremely efficient. So we have a sphere. I'm projecting on the sphere, right? Okay. I just kind of like, well, that sphere will do. And this is our camera. Okay, this is the camera that kind of like we, say, tell me turn off the light, okay? This is our filming camera and same camera I'm projecting with. Okay, this is the same camera, this one and this one. So you're projecting on the sphere. And then when you want it to reflect on the ground, the very cool trick is taking the axis and making the scale -1 by y. Okay, and that's what it does. It's kind of putting the camera under the ground. Then you can move it up and down if your ground not exactly sitting where it's supposed to sit, but it will give you very cheap and correct, absolutely correct reflection for the background. Now it will be not correct reflection for the foreground characters because they're standing closer to us, okay, and they will reflect differently. And that's why I did use some kind of very rudimentary roto and the keying and okay, that's alpha. So that's the keying and roto of the first character which is walking there. Let's go back to hide stuff. Okay, I did mask it. And then I projected this character exactly in position where he's supposed to be, supposed to walk on the card. Okay, so my sphere is like very far away somewhere, but this person is actually in a proper position. And that's why when we see that, we can see that the person is actually absolutely properly reflected because she's walking, or he, in the proper position and reflected properly. If I would project her on the background, she will fly somewhere there. That will be not correct reflection. And this does the job already as a base. You see, that I didn't do it for the second character because I was lazy, but you've got the point. Okay, reflection, you have to separate it to different areas, to different depths, otherwise it will not work. And then I just comping on top of each other. This is another thing, how you comp reflections, you over them one on the top of other. Okay, you're not plussing reflections inside of itself. And this is advice when you need to add reflection, for example, to the window. You have a window, and then like I was comping shot yesterday, and I'm so sorry I cannot show it to you because that will be really overkill. I can't. But there was a window with reflection of outside area, and then supposed to be character, CG character walking next to it, and we need a reflection of this guy. So how you adding reflection of this guy? You cannot plus it because in this reflection you already have reflection of the environment. You cannot just plus him on top. You have to over him. But if you overing, you're saying, well, that's the full reflection of him now. But this is glass, which is transparent. So when you comping, I don't have time to show it to you, but when you comping one reflection on the existing reflection, you have to get rid, in the areas when you're comping your guy, you have to get rid completely of original reflection. You need to kill it. Meaning you need to see just diffuse of the material which is inside. Okay? With the water, like it will be just gray. It's easy. You just kind of like, if there is some reflection, just grading this dark, then adding a little bit of black point up, so it will be grayish thing. That's fine. But in the complicated cases like a marble or window inside of the house, you need to clear reflection. The best way and the only way to clear reflection, frankly, is to stabilize this area. You're stabilizing this area, and then you can I show it to you now? No, I can't. Maybe I will show it next time, but when you're stabilizing the area where the reflection is happening, let's say, and there was reflection coming here, and then you making the time equal and minimum, okay? That's all reflection that's happened will slowly disappear. I hope it does make sense to some of you. I do understand I'm talking now a little bit in the air. I probably will have to kind of show to you exactly how it's done, okay? But let's come back to the reflection. So one reflection on top of another one, absolutely over. If it will be plus, have a look how it will look like. It will look like that. You will see trees behind it, and when you will comp, you will see what I'm talking about. So that was the lady on top of the background in reflections. Then I was kind of like adding rain hits. Very simple. Now, simple and efficient. So you can see here, especially, you know, it does the job. Okay, how it was done, observation. You're just looking on the real ones and saying, well, that looks like a little bit of noise, popping, changing the shape and disappearing. I can do that. Okay, so don't go all the time for particles. So I just took a noise. I added to this noise a little bit time echo. So within 3 frames, it will stay there somehow, and then it will disappear. It looks like that. That's the noise, and then it's appearing. Then it's doing some weird stuff. Then it's disappearing. You know, we can refine that. Yes, we can. But of course, rough and edge. And then it's kind of like creating this thing. Of course, defocus, and there is additional thing that you want to add, but as element is separate element. This element also creating some transformation, distortion for the water. So we actually will have, we altering the reflection from the moment the stuff heating. And what is this? Ah, yeah. No. Ah, yeah. So this is our reflection element here. And then a rain hits coming on top in over again, because that's just element, okay? And that's how we're getting our result, which later cut out with it. So that's also important. You see all that here, it's not pre-multiplied, not nothing. I'm just comping element, 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 because all of that is going to be part of the one puddle. And that's the alpha of the puddle, okay? Alpha. Then we're distorting all together 1 time and not 5 times, as kind of like people like to do. And here we go. Now we have our puddle, not the most amazing puddle of the world, but if I will get commands, it's going to be like that. Okay, What? This. So always try to divide and conquer. As always, it's kind of like big part of the workshops that I'm doing. It's just you always have to do that. What is this? Ah, Rotos, I stole it from Siddharth. I think you recognize these things. Okay, now last thing, Fresnel. I promised you, and I'm showing you. Now, I'm very much not mathematical guy, but I will try to explain what Fresnel is. Okay, so this is the, that's in 3D world. And this. Okay, fine. So there is a camera, and there is a scene. Where is my scene? F. Ah, okay, good. And camera is doing this. In beginning, camera is exactly in front of that. Okay, this is X, this is Z, and this is Y. And I asked the scanner render to output normals. By default, scanner render will output for us normals which are in the world space, meaning in the world there is X, there is Y, there is Z, and its red channel will just go from -1 if your object is pointing completely to the one direction. And let's have a look on the red channel. And I think we don't need protection anymore. Red. That's our red. Okay. Here everything will be -1, everything which is pointing to the -X and +X +1 by red. Green will be +1, -1, and blue, and that's cool, it will be the angle towards the Z and the -Z. Okay, so here it will be 1. I don't know actually why it looks so weird. Just give me a second. Rec 709. That makes more sense. Okay, and that's our Fresnel. The problem is, from the moment camera is starting to rotate, we're like, oh, wait, where are you going? Okay, because this is world normals. This is not camera normals. And in order to create camera normals, you need to say kind of like, guys, you staying with me. You going to rotate together with the camera. And there is like a few Fresnels, like I took the simplest one, which I have no idea what he's doing. And I remember I did put it together. But the cool thing is you have this color matrix 4, and you can just add the world matrix of your camera to this guy. That's what it does. Okay, this is the world matrix of the camera, cancel, and then you're inverting that, and he's doing all math for you. And now when I will have a look here, and I will go to the all channels, camera is rotating, but normals are rotating together with the camera. And that's why if I will go and I will have a look at the blue channel, it's always will give me the Fresnel. Okay, and now if we'll invert it, we have very cool map for us, our reflections. So we'll say if camera is coming to the object and doing that, and we need to add reflection on the ground, if we're using Fresnel, it's naturally will do that when the camera is going down, the reflection is starting to be stronger, less. And it does work important. It's not just for the water. Any reflective object going to react in this way. Not any, except of the mirror, and mercury and stuff. But semi-transparent stuff and so on and so on. And I'm really getting to the end of the lesson. I think I covered everything. Now, if you want me to talk about something, ask now. We have 4 minutes, or we can just finish this lesson. If you have questions about technical little things, how did I do that, I can also.
Alexey, I have a question about the reflection on the ground.
Yep.
So you use the same camera as the projection one, but you invert it in Y with the axis. That did the trick of what I missed to put exactly the same position you need to get the reflection of the guy walking on the.
Yeah. Okay, good. That was quite simple. So that's the guy. How did I do the trick actually to put him, her? I have here the grain master undistorted, and that's what I was doing. I will disconnect. So I'm creating now a little scene. I'm breaking everything, and I assume that my ground is here. That's my card. I will show you guys in a moment. Minus 90,000. That's it. Okay, that's the basic thing. Okay, so check this out. This is my ground. Okay, and the person is walking on the ground. Okay, now let's add another card, which is I'm going to merge it, and I will say wireframe, and that's super easy. You will see, and I even don't need half an hour for that. Now this card will stay as it is. I will make it bigger. I will make it less bigger. But now, sorry. Now what I can do, I assume that this card is on the ground. I can also project this person on the card, but is in very simple way. Sorry guys, you will have to believe me that. Let's make it 5. Okay, this is one card. Just let me see that I'm fine here. I just have too many things there now around there. So this is one card. This is another one. And come on guys, can you be not visible? Sorry, it's just so even without projecting this person on this card, okay, now we have it. If you will move this card now in the Z, and you know where the center of the card, and this is extremely rudimentary what I'm doing now, that's the center, that's it, that's where this person is contacting the ground. That's the position of this person in 3D space. Okay, I assume that ground is in the proper place and tracked properly, and I did check it. So what I will do, I will just make set key, and that's kind of like really no kind of like not complicated, nothing like rocket science. Set key, and that's what I did actually when I was comping. And now I will go and move here because the person is there. Set another key, of course, and that's it. So that's how you position the person in the right place. Now, the last frame and you're done. And trust me, it's in proper place, because like as a result, you're getting pretty much good confirmation of, well, that's pretty precise, I would say. Yep. All right, and we have 2 more minutes. More questions?
I had one question about this kind of reflection. Might we use a ray render technique and a reflection not to make the same kind of reflection there on the water?
Yes, you can. Basically, instead of rotating the camera, you can bring the ray render. I will bring under user one because it's kind of like easier. And then we'll say, well, that's the reflective geometry. And then you will have to put the card of the ground. I mean, it will be just card 90 degrees. Let's make it big. And you should get it. You should get it kind of like minus 90. It should work. Reflective geo-reflected opposite. Reflected, reflective. I don't see it right now, but it should work, basically. Yeah, it's the same. It's just going to be heavier. And here I'm like, well, that's easy trick, and it's definitely faster than ray render. So, but the idea will be the same. You will have to first to create your environment reflection here. So you definitely will want to position your reflection in proper 3D space. And then you can use the ray render. You want to use ray render when you have complex environment. Okay, ciao Jan, see you. But if you have a plate, why should you? You could, but like, you know, it's just way faster. But you absolutely can do that, yes.
Okay.
Next question?
I would like to add a little thing about why we need to over the reflections rather than plusing them. It's because, so let's put it in a simple way. We see the energy of light that travels in the world. So basically, whatever is reflecting on a surface, it's the radiance of the photon, okay? So if the object is not reflecting, we see through it. So we see 100% of the light passing through it and bouncing on whatever is beyond the object. If the object is 100% reflecting, we see 100% of whatever is being reflected. If we see 50, we see 50 of what's behind and 50 of what's in front. If we plus, we're going to see 100% of what's behind and 100% of what's in front, which is not correct. So basically, if we over it, for example, we hover with 50% of alpha, we're going to see half of what's behind and half of what's in front, and that's correct. That's why we should hover the reflections. I don't know if it's clear or if it makes sense.
It does. No, it does. It does.
Yeah, the reason.
And now we really have to go because we all have morning meetings. Thank you very much for this time. And we have to cut now.
Alexey, can I have 15 seconds?
Yeah, shoot.
Let me share the screen.
Yep.
I need to share this. So,
Dude.
You know what I'm saying. Yeah. So it's like this miniature shoot we did together, like years ago. And so it's like really clear, like there's like a great example of like how there's water falling everywhere, but like we mostly only see the one that is on top of the bright stuff. But there's also water here, so it's like that's a good example there.
Yeah, that's right.
So exploding Warhammer car. Yeah, that's it. Thank you.
Cool. Good memories. Okay, guys, I have to run. Thank you very much. Ciao, ciao.
Thank you.
Thank you. Bye bye.
Thank you.
Bye.
Bye.
Thank you.
As far as we think it is possible without creating issues, without the image breaking apart. So I put that in a delivery note. I'm just letting you know. So this information gets passed on either in the delivery comment on the QuickTime or as a